think back to when we started graphing lines. When we graph a line, what does that represent? Like, let's say I graph the equation y equals 1/3 x plus 1. What does that mean? What is that graph indicating? Maddie, what do you think it indicates?
That it's going to cross the y-axis at 1.
It's going to cross the y-axis at 1.
It's a 1/3 angle slope.
Okay, but what is this line? Okay, so it's going to cross the y-axis at 1. And you said that has a slope of 1/3. So let's do 1, up 1. No, is it positive 3 or negative 3?
Positive.
Up 1, right 3. Like that. So all of these points, what do these points represent? What are they? And then when I attach this line, which I did an amazing job of making it straight. Okay, what does that mean? What does that line mean? What are all of those points? You guys remember? Remember when we were substituting in and we said if x equals this, then y equals this? So remember clear back there? Well, if x equals 0, what does y equal? 1. If x equals 3, what does y equal? 2. These are all solutions that make this equation true. This point right there, this random point, I have no idea what that point is because it's all fractiony. That's a solution that makes that equation true. How many solutions are there for the equation y equals 1/3 x plus 1? There are infinitely many solutions. This line goes on forever. I only draw that part of it because I don't want to be drawing the line all day long. But that line will go on forever. So how many solutions are there? Infinitely many solutions. Now, all through the school year, whenever I have 2 variables, what do I say? Can I solve an equation with 2 variables? No. What do I say after that?
No, for what?
I say I would need 2 equations to do that. Guess what we have today? 2 equations. We have 2 equations. Now, how many solutions does this equation have? 1. No. How many solutions does this equation have? Infinitely many. How many solutions does this equation have? Still infinitely many. Is it the same numbers? Is it the same infinity? No, but it's still infinitely many solutions. The question is, how many solutions are there that work for both of those?
That's a good question.
So Ashley just went, what? Should we see if she's right? Let's test it. Okay, so we graphed that line, and everything on this line is a solution for this equation. I want to change colors. And so we're going to graph this line. Where is it going to cross? I'm going to grab, I have my popsicle sticks. Where is it going to cross the y-axis? Anastasia. Y equals negative 3x plus 11. Where does that cross the y-axis?
3.
No, that's the slope. So what's the other part?
11.
11. So it crosses the y-axis at 11. So you're going to go precisely right there. And then this negative 3 is what, Jackson? It's not the y-intercept, so what is it for this line? Someone help him out. What is it, lady? The slope. So it's negative 3, so we know it's going to go down, and we're going to put in a 1 right there because it's a fraction of negative 3 over 1. So we're going to go down 3. 1, 2, 3, 1. Did they have it crossed yet? No. 1, 2, 3, 1. 1, 2, 3.
Look at that.
They crossed. I'm going to keep going. 1, 2, 3, 1. 1.
That's crazy.
Where did they cross? How many points did they cross at? 1. And which point was it? It was the point 2. That is the, so Ashley was right. How many points do they have in common? 1. They have 1 point in common. How many solutions does this system of equations have now?
Plenty. 1.
1. I mean, sometimes 1 is plenty, right? It's all right if we only have 1 solution. Now we're going to double check that this really works. When it says, verify that the ordered pair named in part A is the solution. So we're going to say, does this ordered pair really make that equation 2? True. So wherever I see a y, I'm going to put in 2. So 2 equals 1/3 times x. What's x?
3.
3 plus 1. So what's 1/3 times 3?
1.
1.
Wait.
Does 2 equal 1 plus 1?
Yeah, no.
Yeah. Absolutely not. Yes. 1 plus 1 equals 2.
Yes, it does! 1 plus 1 equals 2. Does 2 equal 1 plus 1?
Yes.
Is this a solution?
Yes.
Happy day! It's a solution. Let's try the other one. So this one we have y equals negative 3x plus 11. Y is still 2. X is still 3. What is 3 times negative 3?
Negative 9.
Is negative 9 plus 11 2?
No.
Wait. Yes. Whoa.
Does negative 9 plus 11 equal 2?
Yeah.
If we flip that, does 11 minus 9 equal 2?
Yeah.
Yeah.
Yes. So does this one work?
That's
Yeah.
good.
That one also works. Yay! Did we do it right?
They don't have noses.
I never draw. I mean, it looks weird with noses.
It's almost
Look, now it looks wrong. Okay, let's look at the next one. These are not on your paper because you only have 4 questions on your paper for you guys to do, so I'm not doing any of them on the board.
So I feel like I forgot how to do this.
But we're going to do another one. If you don't remember how to graph, then that is a problem. Now the last one, they were both in slope-intercept form, but on this one they are not both in slope-intercept form. So I'm actually going to start by putting this one into slope-intercept form. We know that slope-intercept form is y equals mx plus b. M is the slope, b is the y-intercept. So I need to get this x away from that y. Coulter, how do I get that x away from that y? Well, what's happening between the x and the 4? You subtract. So we're going to subtract x. So we have 4y equals negative x plus 4. Now, I still have a 4 in front of that y that I do not want in my life. So Peyton, how do I get rid of that 4 that's stuck to the y? Divide by 4. And if I divide that by 4, I divide everything by 4. I recommend putting a divide by 4 under everything. Some of you keep doing like the big one and then a 4 underneath, which technically is not wrong, but then you only divide the first one by 4. You're not dividing the second one by 4. So make sure everybody gets a piece of that 4. So this goes away. We just have a 1x over 4, so that's going to be negative 1 over 4x. And then what's 4 divided by 4? 1. Okay, so we have negative 1/4 x plus 1. Bella, what's my y-intercept on this equation?
1.
1. Right, what's the slope on this equation? Negative 1/4. So we go down 1 over 4, down 1 over 4, up 1 to the left 4, up 1 to the left 4. I'm going to connect my dots. I do like to actually draw every dot with these, because look, when I drew my line, I didn't hit that dot very well. Hopefully you guys are drawing straighter lines than I am here on the board. But if I have a dot there, then I know that that dot is really there, so that wherever these two cross, I have a dot. All right, so this one's already in slope-intercept form. We have y equals 1/2 x plus 4. So, Emsley, what's the y-intercept on that one? The blue one. That is the slope. 4 is the y-intercept. So 1, 2, 3, 4. And then I just told you the answer to this one. Landon's not here. Cora's not here. Where is everybody today? Ashley, what's the slope on that blue equation? 1/2. So we're going to go up 1 over 2, up 1 and just like that. Have we crossed yet? No, we need to go down here and then right there we crossed. So, where did these two cross? What's this point?
-4,
2.
and 2, yeah.
So -4, comma 2. All right, so now we're gonna verify that it really works. So y, so 2 equals 1/2 times -4 plus 4. Well, what is 1/2 times -4?
-8.
What's half of -4, guys?
-2.
-2. What's -2 plus 4?
Positive 2. What? Yeah. Oh.
Is -2 plus 4 equal positive 2?
Yes. Yes. No. Yes. Yes.
Does
Yes.
4 minus 2 equal 2?
Yes.
Yes. So, does it work?
Yeah.
Yeah, let's try on the other one and see if they work. Now, I put this one in slope-intercept form, but when I'm substituting in, I don't need to worry about that. So we're going to have x. Our x term was -4. -4 plus 4y. So 4 times 2 equals 4. So what is 4 times 2? 8. -4 plus 8 equals 4. Does -4 plus 8 equal 4? Does 8 minus 4 equal 4? Yes. So does it work? Happy day! And they both work. So that's today. So the biggest problem, the biggest place you're going to make a mistake today is if you graph them wrong, they're not going to cross in the right place. But you will know that. Let's say I graphed this one wrong and I graphed it with a positive slope instead of a negative slope. It's going to cross somewhere clear up here. And when I substitute those points back in to verify, like let's say it crosses clear up here at this point, 8, 8. When I substitute it in, it's going to work for one of them. It's not going to work for the one that you graphed wrong. And that will be your clue that, whoo, you did something wrong. So if when you substitute them in, they don't work, you need to figure out how you graphed it wrong. Probably, knowing you guys tend to forget about your negatives on your slopes. So if you're gonna, or you put it into slope-intercept form wrong. So if you show your work, I can help you find out what's wrong. You can also consult with the people around you. But that's it today. You only have 4 of these to do. They're pretty straightforward. And they are all gonna meet at happy, pretty points. They're not gonna meet on any fractions. So if you get 2 that meet on a weird fraction, then you know you did that one wrong too. Sound good? We feeling good? You guys are super quiet. I'm gonna guess it's Monday tiredness.